Welcome to The Explainer. Today, we are tackling a huge question in AI. How does a machine actually learn to reason? All right, let's just jump right in because this is a really cool puzzle. You've got these brand new large language models, right? And when they first wake up, they're not smart. They're just a giant chaotic mess of random numbers, like a brain with no thoughts. So the big question is, how do we get from that, from total chaos, to the amazing tools we use every single day? Well, it turns out it's not this slow, steady climb. The story of modern AI is actually a story of two giant leaps forward, two huge, distinct jumps in what these models can do. So the first big leap happened back in 2022. We can call it the instruction jump. This is when ChatGPT burst onto the scene and blew everyone's minds by showing that these models could actually follow human instructions. But then, just a few years later, we got the second leap, the reasoning jump. This was a whole different level. Models like DeepSeek R1 started showing they could perform really complex, step-by-step reasoning. And let me tell you, that absolutely shocked the open source world. It changed the game again. Okay, so to really get how these jumps are even possible, we need to look at the whole trip an AI takes. I'm talking from day one, as a bunch of random numbers, all the way to the finished, polished tool. You know, every single one of these powerful AIs, whether it's a GPT-4 or Claude, starts out as something called a base model. Now, this thing has read pretty much the entire internet. Think all of Wikipedia plus trillions more words. It knows a lot, but it's totally unfocused. It's great at predicting the next word in a sentence, but you can't have a conversation with it. It can't follow an instruction. So even with all that knowledge, it's basically useless for what we want to do. So here's the roadmap. It all starts with step one, just a random jumble of numbers. Then step two, pre-training, is where it reads the internet and becomes that base model we just mentioned. After that, we get into the fine-tuning stages. Step three, that's supervised fine-tuning, or SFT, where it learns to follow basic instructions. Step four, preference tuning, teaches it to be, more helpful and less weird. But the real magic, that final critical leap that gets us to reasoning, that all happens in step five, reinforcement learning. And you know who had a great way of explaining this? The AI legend Yann LeCun. And he said this way back in 2016, which is pretty wild. He called pre-training the cake. That's the foundation. Supervised fine-tuning is the icing on the cake. But reinforcement learning, that's the cherry on top. It's that final, crucial touch that makes the whole thing perfect. So what is this cherry on top, this reinforcement learning thing? Well, boiled down, it's really just about learning through trial and error. And honestly, the best way to get it is to think about it like an old-school video game. So let's say our AI, our agent, is Pac-Man. And Pac-Man has one mission and one mission only: get the highest score possible. At any given moment, the agent, Pac-Man, has to make a choice. It has to take an action. And in this case, the choices are simple. Go up, down, left, or right. And where does it take these actions? In its environment, which for Pac-Man is, of course, the maze. Okay, and here's the most important part. Depending on what happens after that action, Pac-Man gets a reward. If it eats one of those little pellets, boom, +1 point. Awesome. But if it runs into a ghost, ouch, that's a -10 points. So the whole game, the entire learning process, is just Pac-Man trying to figure out a strategy that gets it the most points possible over time. That's it. All right, so that all makes sense for Pac-Man. But how in the world do you apply that to a language model? I mean, how do you give a reward for writing a good sentence? Well, the idea is actually pretty simple. You create something called a reward function. So let's say you ask the model, what is 2 + 2? If it spits out 4, great, you give it a high score, say +1.0. If it says 5, well, it's wrong, but it's in the ballpark, so maybe it gets a little reward, like +0.8. But if it answers with something totally random, like the letter D, you hit it with a massive penalty, like -10.0. And the whole point of the training is for the model to tweak its own internal wiring over and over across millions of attempts to chase those high scores. Here's the key. You're not telling it how to solve the problem. You're just rewarding it when it gets it right and punishing it when it gets it wrong. It has to figure out the how completely by itself. And this is where we get to the real secret sauce. Because while the algorithms that run all this, PPO and GRPO are super complicated, they're not actually the most important part. The real magic isn't in the algorithm. The real secret, and believe me, this is the hardest part of the whole thing, is coming up with clever reward functions. You need ways to score the model's answers automatically, without a human having to check every single one. So you get creative. You can check, does the answer follow a specific format we asked for? If it wrote code, does that code actually compile and run? For math problems, you can score it based on how close it is to the right number. You can even, and this is happening more and more, use another powerful AI to act as a judge and give a score. And this really gets at the massive shift in how we train AI. The old way was all about data. You needed millions of perfect examples written out by humans showing the AI exactly how to do something step by step. But with this new RL approach, well, now reward is king. You don't need to show it the process. You just need a really smart way to check if the final answer is correct. The AI figures out the messy middle part, the reasoning, all by itself. So if there's one thing to take away from all this, it's that reward is king. Our ability to teach an AI any new, complex skill, it all comes down to how well we can define that skill and build a function to reward it automatically. And that leaves us with a really big, exciting question for the future, doesn't it? If the reward function is the key that unlocks these incredible new abilities, what should we teach it to do next?